So clouds, we have talked about the water cycle, precipitation, and now we need to talk about the condensation portion of the water cycle, which inevitably kind of sort of ends up to be clouds. Not always. Obviously, in the winter, we can have condensation build up on our windows when it's warmer inside than outside. In the summer, we can have condensation build up on the outside of like water glasses or drink glasses, things like that. But typically when we're talking water cycle, what we're thinking of when it comes to condensation is clouds. So, still working with Middle School Earth Science Standard 2-4, where you will be able to develop a model to describe the cycling of water through Earth systems driven by energy from the sun and the force of gravity. You are going to be able to identify the natural steps that take place in order to actually form a cloud, identify the different types of clouds, and then identify the characteristics. There are three main subsets of clouds, and they have very specific, what's the word I'm trying to say? Very specific like features that make them them, and then there are a couple that build off of that. So bear with me. Make sure you for sure have your whole group notes in front of you, if not all of your notes, if you're going to do this physically. So let's go. So what is a cloud? It's hard to believe, and even as an almost 31-year-old person, that those big fluffy white things in the sky are just a collection of millions of tiny water droplets or ice crystals surrounding dust particles. I know within class yesterday we talked a lot about how like you could eat snow, you can drink rainwater, but here's the reason why I would not necessarily advise it without some sort of filtering, and that's because it's all trapped around dust and dirt and smoke. That's why we're actually able to see a cloud. So what happens is, thanks to the energy from the sun, it starts to heat up bodies of water. Now remember, bodies of water can be simply just wet concrete in the morning. It can be puddles all the way up to oceans. But it warms up the body of water, which allows then the particles to start moving and gaining energy, and then they start to rise into the sky through evaporation. Eventually, the air actually becomes so saturated or filled with water that the water vapor starts getting closer and closer. Now, when I'm thinking of saturation, typically I'm thinking of like a washcloth or a sponge. So if you happen to help your grown-ups with dishes, whether it is a washcloth, a sponge, whatever, as long as it's not those little silicone thingies, what happens is if you tend to grab it right away, it's dry. Okay, no moisture in it, not a big deal. But as soon as you start running it under water, it starts filling up with moisture or water, and eventually becomes so saturated that as it sits in your hand, the water starts to really drip out of it. That's because the item itself, washcloth or sponge, is completely saturated, meaning that it cannot hold any more water as is. So the water vapor then, because it's collecting onto this dust and now it's collecting onto each other, turns into water or ice. Obviously, it's only going to turn into ice when it's really, really cold outside. That's why you see sundogs in the winter. It's actually the light reflecting off of the water vapor ice crystals that have formed. But yeah, so they form around these particles of dust, so then we can actually visibly see a cloud. Typically, clouds, if you were to get super duper up close and personal, are slightly more gray than they are white, because dust and dirt is gross. It's the best I can say. So this is why I advised against eating snow or drinking like freshly collected rainwater without some sort of filtration, because it has all this dust and dirt and smoke within it, which just isn't good for us. I know, weird concept. So that's how a cloud forms. Now, we really hit on three, but I like to include the fourth one because we experience it, especially this time of year. So we have cirrus clouds, cumulus clouds, and stratus clouds. And as we go through our notes, you will pick up on the things that kind of make them them. Oh my goodness, excuse me. So all three of these terms are Latin, and they're Latin, and their English translation comes into what they actually look like. We'll talk more about those as we get through. I just wanted to make sure that you are aware of those three right away before we moved any further. But fog. Fog is technically a cloud. It's just a cloud at surface level. So for the rest of whole group, I'm just going to hit on one more slide, and it's all about fog. So fog is the suspension of water droplets or ice crystals close to the Earth's surface. Now, you'll notice, especially like if you look at a fog machine or things like that, it doesn't always make contact with Earth's surface. It has just that little bit of space in between. That's because there's a temperature difference between the atmospheric air temperature and the surface temperature, which just may not allow for fog to actually condense right there. So anyway, but the reason why I bring up fog is because you are all on your ways to either earning your permit or start working towards your driver's license. And this is actually something that can super duper affect us, especially first thing in the morning or later in the evening. When you are leaving for school in the fall or the spring, sometimes we might have a visibility issue to where it's reduced enough to where any sort of weather alert might state to you, hey, there's a fog warning, please drive with caution, make sure your lights are on, things like that. You can see from the second picture listed here, those are two cars. They're not just those creepy eyes like staring at you out of the woods or whatnot. It is two cars, and because fog can be so dense, it reduces visibility significantly. So this video is based out of Australia. So yes, they talk about like their climate, but it's very, very similar to what we may experience only during spring and fall. So bear with me. So as we move forward with the rest of our notes, I just want to remind you of our CHAMPS expectations. So your conversations should stay between a 0 and a 1 noise level. Help, remember, read through the notes, reread through the notes, ask a peer, and then raise your hand for support from your teacher. Your activity is you are just working on your cloud notes today. Movement, find your spot in your designated notes location, and then again when you go to turn in your notes for the end of the class period. Your participation, just by showing me that you're taking your notes and turning in your hard copy to the tray shows me that you participated accordingly. And then finally, your success is actually completing the cloud notes. If you have any questions, please reach out. We want to help you, but let's continue on with our notes. So, cirrus clouds. Cirrus is honestly Latin for thin, wispy, tendril, hair, things like that. And that is because as you look up at the sky with cirrus clouds, it looks like this wispy, like mare's tail, which is a horse, just kind of like out in the sky. I like to think of it more like hair or pulled apart cotton candy, because who doesn't like cotton candy? Typically, cirrus clouds only form above 6,000 meters or 6 kilometers above Earth's surface. And that's because they are super cooled water droplets, typically. Maybe not necessarily frozen, but most of the time frozen. Things like that. So cirrus clouds are like what's in this picture, where it's just kind of thin wisps here and there within the sky. Now, cirrostratus clouds are thin wisps that start completely covering the sky. So cirro, as we know, is thin, wispy tendril hair, things like that. But stratus, as we'll talk here in a couple minutes, is like blanket, so to cover, things like that. So cirrostratus still appear above that 6,000 meter or 6 kilometer mark, but they fill up more of the actual sky. So there's more white than there may be blue. The thing with cirrus clouds is that they are so thin that light can still go through it fairly easily, to where we don't really get shadows with these types of clouds. Cumulus clouds. Cumulus clouds, I feel, are like the idealitic clouds. When you think of clouds or when you draw clouds, these are what you are thinking of or drawing. These are the puffy white clouds. Sometimes they have flat bottoms, but they look kind of like cotton balls in the sky. So cumulus clouds typically are our middle ranging heights. So there are 3 different types of cumulus clouds. So cumulus just in itself, the puffy white, or how do they put it, a heap or a pile of cloud. And then I'm going to jump down to, you have alto cumulus, which is still those separate elements, but about the size of fingernails. When, like, if you were to hold your hand out in front of you, sort of a thing, but they typically start to form a little bit higher in the sky. And then we have stratocumulus. So like I said, with cirrocumulus is that not cirrocumulus, cirrostratus is blanket. So these are separate patches or waves of clouds, but they tend to fill up more of the sky. This would be like the bottom larger picture. Finally, we have cumulonimbus. This is those big old thunderhead clouds that you know that you got a good storm coming. These are the ones that we also see hail being formed in, because it's that top picture, the first top picture on your left, where there's enough actual height to it to where when enough draft comes, that hail can go back up and refreeze and all that kind of fun jazz. So these are cumulus. Again, these are typically what you think of. These are what we are starting to experience now more and more, because we're heading more so into spring. Hopefully skipping 6th winter, we'll see. But that's what's going on. And then finally, our stratus clouds. Our stratus clouds are just layers, and they're typically lower to the ground. They're not as low as fog, clearly, but typically they are forming this gray blanket about 2,000 meters or 2 kilometers above Earth's surface. Within stratus clouds, now stratus clouds are what I think of like with the first picture, where it's not fog, but like it is completely covering our sky. Altostratus form just a little bit higher than typical stratus clouds, and you might get more glimpses of the sun kind of peeping through, but it's going to appear super blurry and fuzzy. This is like the second picture down. And then finally, nimbostratus. These are the gray clouds that typically produce precipitation. This is like just those dreary, gross, like rainy days where you're like, oh, I just want to sit at home and read a book under a blanket and not leave, or watch a good movie, things like that. Those are our nimbostratus clouds. So all of these clouds have their roles to play, and they form at different heights within the sky. Stratus clouds obviously completely blocking out the sun, which typically makes it a little bit cooler. And then cumulus clouds, which can cast a shadow. These are the ones that you like look up and you're like, oh, that's a bunny, things like that.